Okay, today I'm covering Lesson 5 of Unit 6, which correlates to Section 8.5 out of our textbook. We will be adding and subtracting rational expressions. And if you remember, rational expressions are basically just fractions that have variables in them. So, just like fractions, when we add and subtract, we've got to have a common denominator. Now, as I put in parentheses, remember that common denominator is preferably the LCM or least common multiple of our denominators. So you might also have heard it called LCD, least common denominator. Okay. Now, to find the LCM of several expressions, you need to factor those expressions, and then the LCM will be the product of the prime factors, each raised to the greatest power. So, again, those are the words to help you understand, for those to help improve your math literacy, but also for those people who prefer the words. Um, and it gives you something to go back to and look at and perhaps understand what we were doing. So, what is the LCM of these expressions? So, if you look at part A, you're given 2x plus 4, and you're given x squared minus x minus 6. So, as it says up there, we need to factor each expression. So when I factor that, you've got x2, common factor of 2, times the quantity of x plus 2. And when I factor this one, I'm going to get x minus 3x plus 2. Okay? And whenever we're doing these, if you want to work along, pause it, see if you can factor it before I get there. I'll try to give you some time to do that. Okay? So now I have them factored, and now my LCM is going to be the product of the prime factors. So when you're doing this, you're looking at what are the different factors that you have. Okay, so to start off with, I have a 2. Okay, then I have an x plus 2 here, and I have an x plus 2 there. Those are the same factor, and they're not different. And then I have an x minus 3 right here. So how many different factors? Each of those cannot be factored any further, so they're called prime factors. Okay, and every prime factor that I see when I factored, I need to write in my LCM. So think of my different colors. I got to have a pink, a yellow, and a green. So I've got a pink, and then a yellow, and a green. Okay, now the other thing it said is the product of all your prime factors, each raised to the greatest power. Well, all of these, none of them have an exponent, none of them has an exponent. Therefore, the exponent is 1, and so we are raised, or excuse me, we have raised them to the highest power already. And one way to check it, as I've said, um, if you look at this, a 2 and an x plus 2, you got to make sure you have it in there. And I have it right here, a 2 times an x plus 2. Down here, I have an x minus 3 and an x plus 2. And that just made me catch, why on earth did I write plus 2 when it has to be the same? So that should be minus 3. So now I have an x minus 3x plus 2, x minus 3x plus 2. So I have it. All right, let's look at the next one. Let me go down just a wee bit there. All right, so part B says we have 3 terms this time. So I have an x squared plus 3x minus 4. And I have, that's blinking, I have x squared plus 2x minus 8. And I have x squared minus 4x plus 4. Now, each of those need to be factored. Each needs to be factored. And so x squared plus 3x minus 4 is going to become x plus 4, x minus 1. So pause right now if you want to try to factor those on your own real quick and then come right back. X squared plus 2x minus 8 is going to be x plus 4 times x minus 2. And then x squared minus 4x is going to be x minus 2 quantity squared, because that's a PST that we've talked a lot about. So those are my factorizations. Now my LCM, and I'm going to go use that highlighter just because it helps. I think it helps to see. So I have an x minus 1. I have an x plus 4. And I have an x minus 2. So those are my different factors that I need to see. So I've got to have an x plus 4, an x minus 1, and an x minus 2. And then again, you're looking for the greatest power. Well, again, no exponent on any of these, but when I get down here, I have a squared, so I need to have a squared on that one. And also, you can check it. Do you see this in your LCM? And it's right here, x plus 4, x minus 1. I have an x plus 4 and an x minus 2. Well, there's an x plus 4 and there's an x minus 2. And this one says I need two x minus 2's, and I have it. So that would be my LCM. Okay, now on to adding and subtracting. So what is the sum of the two rational expressions in simplest form, and state any restrictions on your variable? Okay, now the important thing to remember about this when you are doing a sum, or on the next example we're going to do a difference, okay, you are multiplying by 1, okay, um, and I'm pretty adamant that I see a 1 in your problem when you do that, okay. But watch how we do this. So you're looking for the LCM of these two things. The first thing, just like we did up here, is we have to factor. So this guy factors, I have a common x, and it becomes x minus 1. So if you need to use the highlighter, you can see I have an x minus 1 right here, and I have an x minus 1 right there. And then I have an x. So the point of it is our LCM, or LCD, whichever one you want to call it, least common denominator, is going to be x times x minus 1, because I have to see both factors in there. Okay? I don't think I got highlighter that time. I didn't. Alright, so here's my x right there, and here is my x minus 1. And when you highlight it, you can also see I've got a yellow and a green here, but I don't have a yellow and a green here, so I need a green one, which is my x over my x. Okay? Or however you want to think about it. You got to multiply the bottom, an x, and now my bottoms will look the same, but whatever you do to the top, you have to do to the bottom. Whatever you do to the bottom, you have to do to the top. And this is where I get that 1. This is your 1. So you're multiplying it by 1 in the form of x over x. Okay? So when you do this, what then I write whatever I have on the bottom, so that's my denominator. And when I multiplied it by this, this allows me to write the numerators all over the same thing. So this is x times x plus 1 plus negative 2. And now, of course, we're going to simplify that. Let me move that up a little bit. I don't want to run out of room. Nope, didn't get that. Move it up a tad. Okay, so I have to remember to distribute this. X goes to both items in your parentheses, so that's going to give me x squared plus x, and of course plus the negative 2 is minus 2, over x times x minus 1. Then you always have to consider whether or not this top can factor. So I hope you see that it can, and that of course is going to be x plus 2 times x minus 1 over x times x minus 1, and then I have a x minus 1 that is a factor of my numerator and my denominator, which leaves me with x plus 2 over x. So that's my answer. And I have to state the restrictions on my variables, so I look back at my least common denominator. That's the easiest place to look, because those are the items that 0, you have to figure out what makes those things 0. So x cannot be 0, and x cannot be 1. So we're good on that one. All right, so look at part B. Okay, again, the first thing we're going to do is factor. So I'm going to factor this bottom, x plus 2, x minus 2. All right, so you're looking at your factors, and whether you've got your highlighter, there's an x plus 2, and there's an x plus 2. This is a different one, so that's an x minus 2, but hopefully you can see this needs an x minus 2 on the bottom. So when I write x minus 2 on the bottom, I have to do it the same thing to the top. And so I'm going to write it all over that same numerator, excuse me, that same denominator. Okay, I didn't multiply this by anything, so I'm just going to carry the x down. And 1 times anything is that anything. So 1 times x minus 2 is going to be x minus 2. And I simplify that, combine like terms, gives me 2x minus 2 over x plus 2 times x minus 2. And then we look to factor that top, and that top becomes 2 times x minus 1. Now, if you can see right then that that's not going to cancel with either of these, so you don't have to worry about it. And you can actually leave it in this form, or you can write it in factored form. It does not matter. But this, we still have to state our restrictions. And our restrictions going back to my denominator is x cannot be plus or minus 2. Y'all are pretty good about that. Okay, so on to the next page. What is the difference of the two rational expressions? So what's the difference is this time we're going to be subtracting instead of adding. Otherwise, same process, but I'll get there when we talk about what the main difference that you have to remember. So again, we're going to factor our bottom, which is going to be x minus 2, x minus 1. And if you can, I hope y'all can see by now. So I got, oh, I didn't close them. So sorry. All right, we'll go ahead and do it. So I got my factors. I got an x minus 2 and I got an x minus 2. But I also have an x minus 1 over here. So I'm missing the x minus 1. My bottoms have to be exactly the same for me to combine my tops. So x minus 1 over x minus 1. Got to show me the top and the bottom. And so on the bottom, I'm going to have x minus 2 times x minus 1. Now, on my top, it's going to be, it's x minus 1 times x plus 3. And I'm writing this out because I want, it's so important. This negative, we talked about this before in our last lesson, how that negative, when it's in front, you can put it to the denominator. You can put it to the denominator, you can put it to the numerator, or you can leave it out front. But when you combine these fractions, you have to put it to the numerator. So I put a minus, but you have to remember to distribute that to all parts of your numerator. Okay? And that's going to be the thing that's going to trip most people up, so be careful of that. All right, so we're going to simplify our top. Bottom doesn't change. When I FOIL that out, I'm going to get x squared plus 3x minus x plus minus 3. And then I distribute that negative. It's going to give me minus 6x minus 7. So next I'm going to go to simplifying that, and I have an x squared, and then I have a 3x minus x is a positive 2, minus 6 is going to be a minus 4x. And then I have a, I'm going to put a little different, I'm going to put something different. I'll put that so you can tell that, well, those don't look any different. My bad. Let's change that. Um, let's just do this. So I'm combining this and this. So negative 3 and negative 7. Um, and I changed it. That was silly me. Y'all probably yelling at me right now. But that's a plus 3 and that's a minus 1. That is a minus 3. Ah, I fell for it. I wasn't paying attention. My bad. Minus 6x minus a negative 7 makes it plus 7. So I apologize if you were screaming for the last 30 seconds. But of course, negative 3 plus 7 gives me plus, wrong color. Negative 3 plus 7 gives us plus 4. And the bottom is x minus 2, x minus 4. So does this thing factor? It does. I'm so glad you noticed. That is x minus 2 quantity squared. And that, of course, is still over x minus 2 times x minus 1. And I have 2 on top and 1 on bottom. And so my final answer is going to be x minus 2 over x minus 1. What are my restricted values? Remember, you want to go back to your original denominator. So it's up here, my LCD. That means that x cannot be 1 or 2. All right, on to part B. Again, we're combining terms. We're going to factor. This is going to be x plus 5, x plus 1. I have an x plus 5 over here, so I need my x plus 1. So even though we've only done it to 1, um, sometimes you have to do both. So just be flexible. X plus 1 over x plus 1. Okay, so when I multiply these out, that's going to give me x plus 1 times x minus 1, and then minus that numerator, because I didn't have to multiply this by anything, because he already had the denominator that we needed. And that, of course, is over x plus 5, x plus 1. And I'm going to multiply this out, and that's going to give me x squared minus 1, because that's my a plus ba minus b, which gives me a squared minus b squared. And then I'm going to distribute that correctly this time so you don't have to yell at me at minus x minus 3. And I have the same denominator. Okay? And continuing, if I simplify my top, that gives me x squared minus x minus 4 over x plus 5, x plus 1. Now, can I factor this? I'm so glad you said no, because there are no factors of 4 that subtract to give me 1. So we're done. We don't have to go any further. We just have to give our restrictions. X cannot be negative 5 or negative 1. Now, in case you're questioning, can you look just at your answer? You can, but notice over here it's simplified, so you don't want to forget what you canceled out. So that's why we go back to the beginning. Okay, so the next thing I'm going to talk about is something called complex fractions. I know you're familiar with them. I know you've done them. You might think they're really gross. All right, but let's talk about what a complex fraction is. I don't want that color. Sorry. That bothers me. Complex fraction is basically it's just a fraction in a fraction. Okay? A rational expression that has at least one fraction in the numerator or denominator or both. Okay? I'm going to give you an example. Actually, before I do that, well, I'll show you. Let's do this. So, a complex fraction would be something like 5 minus 1/4 over 6 minus 2/3. That's a complex fraction. Why is it a complex fraction? Because I have a fraction that's in the numerator or the denominator or both. Okay, so there are two methods that your book talks about of simplifying them. Okay, the first one is that you can multiply multiply the numerator and the denominator by the LCD of all the rational expressions. Okay, the second method is that you can combine the fractions of the numerator and denominator and then multiply by the reciprocal, sorry, of the denominator, of the new denominator. Okay, this is the method that you're more familiar with. If you had this earlier, your teacher most likely had you combine 5 minus 1/4 and you got a number that was a mixed number, and 6 minus 2/3, which is another mixed number, and then you had to do the keep change flip. That's what multiply by the reciprocal. Remember we talked about that yesterday. That's your keep change flip. Okay, it's a multi-step problem, and that's probably why most of y'all are screaming that we even have to do them right now. However, this first method is a good method, okay, and one that you should consider trying and using. So watch what we do. If I have 5 minus 1/4, 6 minus 2/3, I'm going to multiply by multiply the numerator and the denominator by the LCD. Okay, so I did not want that. I want that. I want you to tell me what the denominators are. Okay? What's the denominator of 5? It's a 1, so I don't have to worry about it. What's the denominator here? 4. Again, 1, so I don't have to worry about it, and a 3. So the only denominators I have to worry about trying to find the LCD of are 3 and 4. And the LCD, or the LCM of 3 and 4 is 12. So I'm going to multiply the top and bottom by 12. So when I do that, okay, remember, you have to do times both things up top. That was really bad. Let's see if I can take that back. Yeah, go down here with it. That one, and then by that one. Okay, so 5 times 12 is 60. 1/4 times 12, or 1/4 of 12, is 3. 6 times 12 is 72. And 2/3 of 12 is 8. So when you simplify that, but notice what happened, y'all. I multiplied by the LCD, and I have terms, but I don't have any more fractions. And that's why it's so powerful to be able to do that. If you don't get rid of the fractions, you've done it incorrectly. Okay? 60 minus 3 is, of course, 57. And 72 over minus 8 is 64. So my simplified fraction is just 57 over 64. So we're going to apply this same process with our variables. So look down at number 4. Give me a little more room there. Okay, so what is the least common denominator? So first off, of course, you need to figure out what your denominators are. Okay, so if I come, where's it? And get my highlighter, and let's go with, all right, so what are the denominators that I have in here? There we go. The denominators, I have an x and I have a y. So I hope y'all are telling me that that means my LCD is x times y. So I am multiplying the top by xy and multiplying the bottom by xy. Okay, so most people don't have any trouble. X times xy, of course, is x squared y. This one, because there's that plus sign, I have to remember to multiply this times that and this times that. Now I'm going to do it, but don't panic if you didn't get it. I'll show you a more detailed approach if you need to after this. But when I multiply 1 over x times xy, the x cancels. So I'm left with just a y first, and then a plus. And when I multiply 1 over y times xy, then my y's cancel, and I'm left with just an x. And so now I have simplified that with one step. Okay? Now, if you have trouble seeing the bottom, then consider doing it like this. So, and I'll do the next one like this. X over 1 over x plus 1 over y. So I'm going to multiply that by my LCD of xy. So what you're doing is you have to multiply every term by xy. So this is going to be multiplied by xy, this is going to be multiplied by xy, and this is going to be multiplied by xy. Now, it's easier if you think about these over 1 because I'm dealing with fractions. But this right here, xy times x, you can see that's your x squared y. But this here is easier for you to see if you know that you can cross out these x's and you're left with just a y. And here you cross out the y's and you're left with just the x's. I only cross them out here instead of here also because then it would mess up when you try to multiply by the other one. But if you need to write it out for each term, by all means go ahead and do that. So I'll probably do that for the second one. Let's go do that. Um, let's go with, all right, I'm going to check it what my denominators are because that's going to help me find. So I have r, and I have r plus 2, and I have r squared plus 2r. So I don't know how many of y'all picked up on it, but we factor this. We always factor to try to find the LCD. So that's r times r plus 2, which is what I have up here. So my LCM or LCD, whatever you want to call it, LCM of my denominators is r times r plus 2, which is the same thing as r squared plus 2r. So when you multiply things, you can do it with whatever makes it easiest for you to see. So I'm going to go and multiply this by, now if I have just a factor, I'm going to write the factor form. So I'm going to write r times r plus 2. And over here, I'm going to write r times r plus 2. Because these are fractions, it might help to write them over 1. And this is a fraction again, so what am I going to multiply this one by? Actually, I'm going to write it over here. I think it might be easier up here. Sorry. Let's write it over here. Move this guy up. Nope. Yikes. I won't. I'll just keep going. All right, so I have this one I'm going to multiply by r squared plus 2r. over 1. So each thing that I've written here, I'm multiplying it by that fraction. So on the top one, to start off with, okay, the r's cancel right here, r and r, and that leaves me with r plus 2 times r plus 6. Here, my r plus 2's cancel, leaving me with just an r, but can't forget that minus sign right there, so there's a minus in between there. And then when I r squared plus 2r cancels with r squared plus 2r, leaving me with r squared plus 4r plus 3. Okay, so to continue, I got to multiply this out. Where'd he go? There he is. Multiply it out, so that's going to give me r squared plus 6r plus 2r plus 12 minus r. So this was multiplying these two binomials. He's still up top. And on bottom I got r squared plus 4r plus 3. And then I'm going to go back to simplifying my top, which is r squared. I have a 6r and a 2r and a minus r, which is going to give me plus 7r plus 12 over r squared plus 4r plus 3. And that then you have to look. Can you factor that? And I'm so glad you said yes, because that's r plus 3, r plus 4. And of course it only helps if I can factor the bottom, and it turns out to be r plus 3 over r plus 1. And my r plus 3's cancel, so I am left with r plus 4 over r plus 1. And that is how it simplifies. So we do have one of those on your quizzes, so make sure you understand it. If you need some more examples, then let me know. Y'all have a great day, and please email me or come see me if you have any questions.